It's Sunday, February 12th, 2017, and this is the Product Mentor Talk. Today, we're joined by one of our mentors, Vikas Batra, Senior Domain Manager, Innovation Scouting over at Nokia, and he's going to lead a very interesting talk on mixed reality interfaces and product management. So let me briefly explain the format for those of you who might be joining us for the first time today. The format is people you see along the bottom of your screen are mentors and mentees within the current session of the Product Mentor Program. Product Mentor Program is a program that conducts 2 sessions a year, pairing up mentors and mentees in a one-on-one sort of fashion in the field of product management to help make better product people, better product decisions, and hopefully better products. So with that all said, I want to quickly go around the room. Everyone can do a quick introduction, a little bit about themselves, whether or not they're a mentor or mentee, and then I'll get back and tell you a little bit more about myself and how to participate. Let's start with the person closest to me, and that person would be Vikas.
Hi, my name is Vikas Batra. Thanks for the introduction, Jeremy. I'm a Senior Domain Manager here at Nokia and looking at augmented reality, virtual reality, among some of the other things.
Excellent. And next up will be Eric.
Hey everyone, I'm Eric. I'm a PM at a company called Media Radar, and I am currently a mentee.
Excellent. And Atma.
Hey everybody. Been a great day, some really nice talks. Looking forward to Vikas's. I specialize in scientific approach to innovation and product management. And I look forward to continuing to learn from all of you. I'm one of the mentors in the Product Mentor Program.
Excellent. A little bit more about myself. I am Jeremy Horn, aka the Product Guy, and I'll be moderating here today. So those of you who are joining us, if you would like to participate, you go to theproductmentor.com/live. On the top of the screen, you'll see the videos. On the bottom of the screen, you'll see a place where you can submit your questions. Please enter your name so that you're not anonymous. We just like knowing who we're talking to and answering questions for. If the questions are topical, we'll get them right over to Vikas right away in fairly real time. I look for a good moment to kind of jump in there. And then as things are more generic, like what is product management, what's a product manager, how do I get product management in my company, etc. Those types of questions I'll save for the end of the talk, but we will also get Vikas to speak to them as well. With all of that said, I think it's time for us to start. And Vikas, take it away.
All right. Thanks, Jeremy. As product managers, one of our roles is to define the product. And we must define something that is valuable, usable, feasible, and viable. Valuable in the sense that the end customer can get something of benefit or utility. Usable, meaning that he can extract that value easily and in an emotionally satisfying way. Feasible, given all the constraints that we have around technology, resources, funding, and so on and so forth. And all three put together, it should be viable. Viable for the end customer, for our organization, and all the partners that are involved in delivering that value. And this mix keeps on evolving all the time. As new technologies become available, things that were infeasible before become feasible. Usability improves. As certain customer needs are met, new needs emerge, making products more or less valuable. As product managers, it's a challenge for us to stay on top of it. And today's talk is going to help you get on top of this new technology trend on augmented reality and virtual reality. The idea here is to present some of the advances in this field and more recent developments, the underlying technology components, and share some of the use cases in augmented reality and virtual reality. For each of us as product managers to examine whether this can add or enhance our current product offering. Can it enable us to create a competitive advantage in our current market? Or even enable us to enter new markets or new segments. And since this is a product mentor talk, I'll talk briefly about the process of making that assessment that applies to any technology, not this technology. So what is augmented reality, virtual reality? A big component of this is it's a new compute interface that redefines how we as humans interact with physical objects and physical spaces. And I call it the spatial user interface. It's characterized by two key characteristics. First, so right now you're looking at this talk, listening to me, and you're probably looking at a PC or a mobile phone, and your eyes are having a physical view. And a part of that view is this screen that you're looking at. Beyond that, you'll probably have a keyboard, maybe a desk, or adjacent to it, a wall behind it. And if you move up, there's probably a ceiling, a floor down. So that's your normal, actual physical view. With this technology, computer-generated three-dimensional images are either added or superimposed to your actual physical view, which case it is called augmented reality, or it completely eliminates your actual physical view and only makes you see the computer generated graphics, in which case it's called virtual reality. Now there's a third term of mixed reality, and because there is this continuum between how much you augment and how much you retain the actual physical view. So some people say augmented reality is where mostly it's the actual physical view with some computer generated graphics, and mixed reality is where it's more or less comparable and it blended. So that's just a terminology issue. For the rest of this talk, I'll I'll keep referring to augmented reality to cover both augmented reality and mixed reality. The second key trait is that it's hands-free. It's not controlled by a mouse or a keyboard. It's controlled by your hand gestures, your head and your body movement. And it looks something like this. So here you see a person standing in his kitchen, the actual physical view, and superimposed on top of it, you see a to-do list on the refrigerator, recipes on the closet, and the forecast and a three-dimensional beach view on top of the island. The soccer video that you see is also part of the computer-generated graphic. It's not a physical television behind it. And like I said, it's controlled by gestures. To understand a little bit better, let's look at the history of compute interfaces. We all know we started with command line interface, a two-dimensional screen with text, a keyboard as a primary input device. We then evolved to graphical user interface with graphical images, introduction of mouse, drag and drop, double click, and so on. We then evolved to touch screen, again a two-dimensional graphical screen with input through fingers in terms of swiping, zooming, pinching, and so on. More recently, we've seen commercialization of voice interface, where both input and output are voice. Examples of this is the Amazon Echo or Google Assistant. In this context, you look at the spatial user interface, where it's projecting a three-dimensional image in your view. And some of the key input devices or output devices are cameras, infrared sensors, and additional sensors. I talk about the input through gestures and head body movement, and the examples of this are head-mounted displays and smart glasses, and I'll talk about it as we go further in the talk. One thing to note here is that a given device can and usually does support multiple of these interfaces. Smartphones, for example, support graphical user interface, touchscreen, and voice interfaces. Augmented reality also is not just about the spatial user interface. That's a key component of it, but the voice interface, the graphical interface around what you see is also part of augmented reality. So to understand some of the technology components behind it and how it is coming together, let's start with virtual reality, which is the simpler of the two to understand. So in order to create a three-dimensional view, the first thing is we need to have two views, one for the left eye, one for the right eye, and let our brain combine them to give it a three-dimensional view, just like it does for our actual physical view. And that's the first thing. And then let's see. Let me show something in action here. I'll switch. I'll stop sharing here, and I will show my screen where I have connected my phone to the PC so that I can show that. And I'll go to YouTube and start a YouTube 360-degree video here to get you a sense of three-dimensional view. So you see there's a video here, a normal video, but there is this icon that you will notice in some of the videos that do support the 360-degree format. So I'll start it here. And the first thing you notice is there are these two different views, one for each eye. Let me just pause it. And let me come back. So I'll show this in action. Sorry about that. I want to bring myself back here. All right. So here's my phone. If you can see the two screens, left eye and right eye. And if I add a simple pair of convex lenses to go right on top of it, I can get a three-dimensional view. And the other interesting thing that has to be supported here, and I'll go back to my sharing. The other thing, okay. The other interesting thing to see here is it is supporting the same pan and tilt. So if I move to the left, I get to see the left view. If I move to the right, I get to see the right view, top, bottom, and so on. In exactly the same way our eyes would see the view. Notice though that as I move forward, you don't see a change, and I move back, you don't see any change here. So it's not in this case tracking what's called as motion tracking, and I'll come back to it a little later. So how is it doing it? It's basically relying on three sensors: a gyroscope, an accelerometer, and a magnetometer that is tracking the movement of our eyes or of our phone, and then refreshing the video such that it seems to move just like we move the phone. Now, interesting thing here is that in order to deliver a good experience, you really need to have two things. One, you need to have high resolution because you're putting a small picture, you're zooming it with a simple convex lens. So you need to have high resolution. And two, you need to refresh it really quickly as there is movement. And the minimum rate that is required is 60 frames per second, below which you start to feel dizzy. Now, in order to deliver that, it requires a lot of computation cycles. So much so that in some cases, when you put it on, it draws a lot of power. And as it draws a lot of power, it consumes the battery, so the battery life becomes an issue. Also, the heat dissipated becomes an issue. So one way to solve this is by creating what has been created by Sony. And let me share my screen again. Is what has been created by Sony. In this case, what they have done is taken the compute of the box that they already have in their PlayStation ecosystem, because it already has a lot of compute cycles there that are needed for even delivering two-dimensional high-quality graphics, and they've connected with a cable to a headset that has a similar capability. It has a display, it has the sensors to track the head movement, like I showed on my phone. They've also added 9 LEDs that track the motion. So as the person moves forward or backward, like I was showing on the phone, you couldn't see that motion. But in this case, as the user moves forward or backward, that motion is tracked. They also have the controller, the same, in the first case, the same gaming controller that they already have in order to enable somebody to control the game. They've also introduced these WANs kind of devices which have sensors, controllers, and also You can see these display LED kind of displays, which are tracked by the system. So these hands come into the virtual view. So as you move your hands in real physical view, they come in the virtual view through this tracking that goes on. Another similar case of delivering this kind of experience is what has been done by Facebook with Oculus. They connect their Oculus Rift headset with a personal computer, with a reasonably powerful computer, and they also have, like you can see, integrated headphones with it, so it gets an audio experience as well. They've also introduced these Oculus Touch controllers that have sensors built in that can track hand movements like waving and so on. The challenge with this, as well as the Sony one, is that both of these are tethered to either a computer or a gaming console in Sony's case. Another interesting thing that Facebook has done is around this Facebook Oculus development platform, which is a platform they've made public that can be used to develop not just games, but also apps, social virtual reality experiences, where each individual can create their virtual avatars. You can see a couple of them in this screen here, that they can then interact with other virtual avatars in what's called as a virtual room. And when I say interact, they can of course talk, they can have a whiteboard that they can share and draw on that. They can look at a video together, they can browse internet together. They could even play a three-dimensional game within that virtual reality environment, like a chess, and use the controller to move the pawns on the chess. So all this capability is being made available by Facebook to developers to develop virtual reality applications. Another space where virtual reality is moving forward or gaining traction is capturing live events like music concerts or even like a simple wedding. So the idea here is to capture these events in three-dimensional, both from a video and audio perspective, to store it, and in some cases edit it if you're making a movie, a normal movie editing function, transmit them, and then play it back on these virtual reality head-mounted displays. On the right, you see a Ozo 360 camera from Nokia that is one such camera that enables recording 3D video and audio. So there's a whole host of innovation that is going on in this entire space, and large players like Walt Disney to mom and pop videographers that record simple events like wedding are looking into how to capture and play back this really immersive virtual reality content. Now moving to augmented reality, which is a little bit complex of the two. We've all experienced it. Here's a simple case of augmented reality that we have seen in football games. For those of you who are not familiar with this, the orange line and the blue line are not on the field. These are drawn only in the computer screen that we see. And there is the intelligence in this that you can see that when a player comes in, like you can see the helmet here, it will not superimpose on top of it. There's also intelligence that it will not superimpose upon this fixed score that is coming on the TV screen as well. And there are sensors that are equipped on the camera that is recording that tracks the movement of the camera, the pan, the tilt, the zoom, and as it tracks that, it gives that feedback back, and that adjusts the superimposing of this computer graphics such that it seems that these lines are drawn on the field. So this is a simple case where there is just one single point of view from the camera, and but in reality, in order to mimic the actual physical view, we need to get we could be moving, get multiple point of views. So let's see it in action for how it works on a mobile phone. So I'll go back to my phone again, and I will start a simple application here. This is an application that has been developed by the White House here to give an example of how virtual reality looks like, what it feels like, and what it can do. The White House, it's an interesting example because it shows some of the functions of White House and so on. So I'll start it, and you'll be able to see what kind of experience it delivers. The first thing in this app is it's going to, as you can see, it's looking for me for a $1 bill, and it's asking me to aim the camera at a dollar bill. And as I put this on the one camera bill, look at what happens. It's recognized the $1 bill, and after that, it's creating this three-dimensional image of the White House. Now, this has not just one point of view. I can move. So if I move my camera left, I can see the left view. If I move to the right, I can see the right view. And what it is doing is essentially recognizing this dollar bill. You can see it's right here, and tracking it. As I move it, it keeps on tracking it. And as I turn it, you can see as I turn the dollar bill, the whole White House is turning as well. So this technique is what is called as a markers-based tracking. So the application in advance knows that it is looking for a marker. In this case, it's a dollar bill. And once it recognizes it, it generates this computer-generated graphics on top of that marker. And you can see, I could even pause it here for a second. And you can see the rain pauses, and I turn around or go around. I can see, even in this paused event, oops. Let's see if I can recover it back. There you go. So you can see even in this paused state that I can see the view, three-dimensional view from different angles. So let's get back to our presentation. Hope you got a taste of this. So I took this with my regular Samsung phone. Nothing special about it. Just it's using the camera, superimposing the image on top of the image captured by the camera. Now Google is taking this one step forward with their project Tango. And what they have done is they've introduced hardware for two different activities. One, it's called the depth sensing, and two, it's called the motion tracking. What it's doing by depth sensing is essentially looking at the view of the camera and assessing the depth of in a grid of that view. What it's doing is it's pushing out infrared beams in a grid. The infrared beam gets reflected back, and then there's an infrared sensor that detects the differential between the two, and based on that assesses how far it is, and then it creates a grid around it. The benefit of doing this depth sensing is that one, you can recognize your environment the way it is from a depth perspective, and then you can add graphics based on that. You do not have to look for predefined markers like the dollar bill was looking in our app. It also has this motion tracking capability with these two cameras that are there that, just like two eyes, track the motion, how the camera is or the phone is moving within this depth-defined environment, so to speak. So they have these two pieces of hardware. It's available on two phones, Lenovo Fab 2 Pro and Asus Zenfone AR. On top of that, Google has this Tango application development platform, which they have made available for developers to make applications on. Now, one thing I do want to mention, even though there is additional hardware here, both of these phones are priced at roughly $500 in the US, which is very comparable to current phone prices. So it's not that these pieces of hardware are adding a whole lot of price to it. So let's take an example of some of the applications that have been developed using this. So here you see an application where this tool, which is a virtual image, it's being shown in the actual physical view of the living room with the couch. And because of the depth sensing capabilities, it can get the exact dimensions as well. And you can see, given the size of the stool, how big it will look like when it is placed here. You can also see here that there is additional information around putting this product in the cart or seeing what the price is and so on. One interesting thing that Google Tango platform also does is that as it gets the depth, it records it as well. So as you move around in space, it remembers the depth of the environment, even though it has gone out of the view. And with that capability, there's another application here where you can see there's an application to visualize the Wi-Fi signal coverage in a house. So using this app, they've actually created the entire floor plan by remembering what is the depth everywhere. And then you go around and you get the Wi-Fi signal strength within that floor plan everywhere and see how much signal you're getting where. However, so far what we have seen, it's all two-dimensional. We still have the screen that we are looking at, but it's not the actual physical view that we are getting in our eyes is getting augmented. Now, in order to do that, we get to smart glasses. It's a form factor that sits right on top of our eyes, that has all the sensors that detect head movement, motion. It also has a full board compute in it. These are not connected to any computer or something like that with a cable. These are standalone devices on their own. Now, there are two examples that I'm showing here. It's a Microsoft HoloLens and the ODG R8 smart glasses. These are somewhat expensive at this point. They're not at a very cheap level. For example, HoloLens is at $3,000, and ODG had an enterprise version they announced for $1,800 and a consumer version for $1,000. Still, pretty expensive, but they have a whole lot of capability built into them. They also have additional sensors, infrared sensors, that can track gestures, meaning you bring your hands in front of them, they can recognize your fingers, and if you're closing your palm or opening your palm or moving your hand, they can recognize these gestures, and using these gestures, they can take input to whatever the compute graphics that is there and take input to control that. But another thing they're doing is they're producing two different images, one in left eye, one in right eye, to get the three-dimensional effect as well. And how is it happening? To understand a little bit better, it's happening in optics. So the actual physical view, the light that is coming straight through the eye, through either a lens like a combiner here or a waveguide here. And there is this display, which is the computer-generated graphics, and a lens with its image coming and getting reflected off of the surface here. So this is a flat combiner approach, which was done in Google's Glass. There is a curved combiner approach, which is done in the ODG glasses that I showed before. And then there is this third holographic waveguide technique. In this technique, the computer-generated graphics is coming into this specialized glass and it is shown thick to show how the light is passing, but it in reality is not that thick. But the light is passing through it using total internal reflection, getting reflected a few times and then coming in. The benefit of this holographic approach is that it can make these optics really thin, really lightweight, and also deliver a better experience. These are not quite commercially available yet, but there's a company by the name of Magic Leap that has had venture capital funding of 1.4 billion that is working on it and is promising something interesting is coming. And Microsoft HoloLens is also based on a similar technology. So pretty promising, although not yet commercially available at this point. So what is commercially available right now? So we have over 40 different smart glasses that are available today with different kind of sensors in them, tracking in them, different kind of optics capability. The good news is that augmented reality.org has compiled all of them at this website and captured all the specification to see which device, which smart glasses does what. And as you look at your own applications or use cases to see what use cases make sense for you, you can also determine which smart glasses make sense for you if you get in a situation where the ideal smart glasses has a price point which is not making it viable. In addition to the hardware, smart glasses need software, and the software primarily has to do four things. First, it has to recognize and track the environment, meaning it has to recognize what is the physical environment and determine where to put that graphic image it has to put. And then it has to track it, meaning as the head moves or the person moves, you have to track it and make sure you keep on adjusting that. That's one piece. The other piece is offline define what the experience looks like. In our case, for example, what will happen when our app looks at a dollar bill? Create the White House, create different season, and if you move from left, this is how it should look like. If you move to the right, this is how it should look like. All that needs to be defined up front. And then when at runtime, it has to execute that and demonstrate that given the environment it is in. The fourth piece is what I call integration with the existing system. So in the example where we saw the stool that was shown in the living room, it also had the price, for example, and card. Now, in order to seamlessly integrate that, there has to be integration between the shopping cart system that may be there and the price management system, which is already existing. So that integration has to happen between the artificial or the augmented reality system and the existing system. Within the ecosystem, there are 50 plus what's called as augmented reality authoring platforms or SDKs. And these are essentially capabilities in these four areas that I mentioned that have been developed by different players in varying degrees, some targeted on certain use cases, some targeted on other. So when you look at developing your own experiences, you don't have to start from scratch. You can identify the right platform and then build on top of it and not start from scratch. Again, the comparison is available at the site listed below. So you need all of that.
Vikas, we had a question that just came in. This one's from Atma, so I'm going to hand it over to him to ask his question.
Hey, Vikas. So I'm curious about the product development path that is involved to begin this process in terms of building or creating an application. Say, for example, we have an e-commerce client create a VR or AR application. What kind of process are we looking at, both in terms of time and cost?
Yeah, so I'll talk a little bit about the process piece, how to go about it, a little bit later in my presentation. So hold that thought. In terms of the price and the cost, it varies. It varies based on what your use case is, how many use cases you're trying to solve, how much of that, like I mentioned, is already available from these augmented reality platforms that are out there. So it just varies based on what specifically you're trying to do. But hold that thought. Maybe let me go through it when I come to the process. Maybe we can come back to it if needed. Okay, cool. So going back to.
So before you do that, just reminding everyone, keep the questions coming in at theproductmentor.com/live. With that said, back to you, Vikas.
So where does this fit in the bigger picture? So at a high level, if you look at the physical objects, we are having this whole trend of Internet of Things where things are getting connected. And as they're getting connected, they're gathering a whole lot of data, and they're sending that data over to our artificial intelligence or analytic systems that are churning that data and making decisions. And some of the decisions they're making is essentially going back to the things and they're controlling these things. So that's the automation or the automated control. Now, these Internet of Things are also sending some of the data to humans, and then humans are manually controlling them. So augmented reality is coming around that human layer. It's a new kind of interface, a different kind of interface to deal with Internet of Things. That's where it's coming up. The other point to be noted here is that as these smart glasses become lighter and they get to a point where they're always on or mostly on when it's needed, it creates this opportunity to do what's called as contextually relevant push, meaning the artificial intelligence and the analytics systems, instead of waiting for people to look at them to see what's going on, they can push something that is actionable or something that does require immediate attention in a given context for a given individual. They can do that autonomously. And what do I mean by context here? It's who the individual is, what his role is, what kind of things does he care about, what kind of things does he care about in that moment. So context has to be defined based on the situation, and you can define it any way it makes sense. But the whole idea is that if you have a smart glasses kind of a device which is always on, it is much more likely that you will respond to an actionable event on that, as opposed to having to get to your smartphone from the pocket, take it out, and see the alert and do something with it. So what does this whole thing is making feasible? To summarize, from an augmented reality perspective, you're getting three-dimensional, augmented video and three-dimensional spatial audio that goes with it. You're getting hands-free operation with input-output from hand gestures, voice, camera, and sensors, and so on. In terms of the display size, it's much larger than smart glasses or iPads, and it could be adjusted depending on what is the capacity of a given smart glasses. As the smart glasses become smaller and lightweight, they would get to a point where they're light, and they're not there yet, but that's where the industry is evolving to. You get greater comfort. When I say greater comfort, meaning when you're looking at a smartphone, your neck is bent, and if you're trying to do some operation looking at for a long time, your neck is not in the most comfortable position, for example. But if something comes on your smart glasses, it's as comfortable as putting on your vision correction glasses, for example. They're always with you. I talked about the contextually relevant push. And then from a virtual reality perspective, it's creating opportunity to offer really immersive experiences. I mean, you shut off your physical view altogether. You put only the computer graphic generated view and audio, and it just takes you in a completely different world. Completely different immersive experiences. The other thing they have the promise to do is in the enterprise scenario, where there's a significant promise to improve productivity, quality, and safety. And in fact, of the 40 odd smart glasses that I showed you earlier on, almost all of them are targeted towards enterprises, and they're getting traction in warehousing and manufacturing the most. So while that's possible, there are still significant challenges that are there. The challenges around technology, on optics, to be able to make these images appear real, to be able to make sure that the images stay stable as you move around. The weight, I talked about the weight right now of some of the more advanced smart glasses is not at a state where it can be worn all day. But there is progress being made with every new version that is released, where the weight is coming down, the battery life is getting better as well. There's also a significant challenge around bandwidth and delay, especially in the virtual reality scenario, where you have to deliver a lot of high resolution picture, and you also have to have a low delay, because as soon as you move, you have to be able to refresh the rate at like I said, at 60 frames per second. And if you really want to get good experience, you really need to get to 90 and even 120 frames per second, which is what the Sony PlayStation does. So there's a challenge there. There's a challenge on the business side of things. primarily driven by price. The Microsoft HoloLens, it's like I mentioned, is at $3,000. Some of the others are less, but still, even at $2,000 or $1,000, it's a significant price. There's still challenges around content, both in virtual reality and in augmented reality, because there has to be augmented reality content available as well. And the application platforms and the entire ecosystem, although there are a lot of players in the space, from a maturity perspective, I think there is still work to be done before this can become as widespread as the smartphones are, for example, right now. If you notice, most of these challenges, while critical for consumer adoption, are not so critical for business adoption. For example, if I'm an enterprise employee and if I have to put on a pair of glasses that do not look sexy or run for 4 hours instead of 12 hours, and I would do that as long as it improves productivity or improves quality or safety. And this is exactly why augmented reality is getting more traction in enterprise segment, whereas virtual reality, which is all about immersive experience, is where it's getting more traction in areas like gaming and events. Given all these challenges that are there, the good news is that a lot of smart people with a lot of money are working to overcome these challenges. In fact, they're competing to solve these problems faster before the other guys. Some of the trends around this: over $4 billion of venture capital funding has gone into this space over the last 3 years. This is over and above the significant investments that are being made by the large players. So, for example, Google, I talked about their Tango program. They have a Daydream virtual reality headset as well. Facebook, we talked about Oculus. Microsoft, they've been innovating heavily with the HoloLens, and some people speculate that they've spent over $1 billion in that. They're also stretching the envelope with the holographic waveguide optics. Apple is rumored to launch AR glasses either this year or next. Amazon, they filed an application with FCC for testing certain new devices. Not sure what they are. So there's a lot of activity going on. On top of that, from a technology trends perspective, they are also evolving that gets us to this future. Miniaturization. Qualcomm, for instance, recently announced their latest generation of chipset with 10 nanometers which means for every 10 nanometers they can put a transistor. There's evolution happening in optics. There's things evolving in the 5G wireless networks that offer ultra low latency and really high capacity and much higher throughput to deliver those virtual reality kind of experiences. There's promise with this WiGig or 802.11ad standard to deliver something like a wireless bus that could be used to untether the virtual reality headsets connecting to more powerful PCs. So all this is working together to offer a better experience at much lower prices. So one could argue, given some of the challenges and the fact that we are not fully at a level of maturity that makes it mainstream, one could argue, let's just wait till it matures. Why do I have to spend the time right now to define what I can do with augmented reality, virtual reality now? The benefit is, if you assess it now, you can get a view of what incremental value you can add, how exactly you can take advantage of these usability improvements. And if it turns out after this that it's not either feasible or viable, that's okay. But you would get a view of what it needs to make it feasible or viable. And then you just track it. As soon as it meets those feasibility and viability targets, you can get into the market and get the first mover advantage. And that's one way to get to competitive advantage. So let's look at some of the use cases that we have, and I've got it into three areas: physical objects, physical spaces, and immersive experience, to help you see where you could apply them. And if you are interacting with objects or physical spaces or immersive experiences, I don't think you can afford to ignore it. But these are just some of the cases, and there could be use cases beyond that. So if you look at physical objects, there are use cases in the entire physical product lifecycle. From design, you can quickly see to create the design in a collaborative way, see the structure, see the aesthetics, and so on and so forth. Okay, let me go back. That's not where I wanted to go. And then in assembly, warehouse, operating, maintaining, the whole host of features. And I call it, basically, you can look at it at a high level as executing a procedure. And you can get the information to augment either on the physical object or next to what it is in terms of instructions to step 1, step 2, step 3 in a hands-free manner. And that itself, you can see, can have impact across the entire product lifecycle. The use cases around marketing, what you see, what you get. The example that I showed on the stool. There's use case on support, where you have this I see what you see, where the support personnel can see what you are seeing with your eyes and guide you. You can also look at the other way, where if you are offering customer support as innovating in that space, getting a customer personnel to support on a video as opposed to just audio can also make the customer support experience that much better. The use cases on education, anything that requires three-dimensional visualization, you can see some examples here, can make that education much easier. Training, same case. Now moving on to the hold on. Moving on to the okay. Moving on to the physical. Let me go back. Yeah, moving on to the physical spaces, again, architectural or interior design, not just in a traditional sense, but there are also new opportunities like this company which is creating designs for retailers to see how to stock what in what shelf and see how it would look like. And before you actually go ahead and make those changes. Navigation, not just in the sense of driving a car, but also if you're driving an aeroplane. There's another case where one I-411 is giving navigation down to the shelf in the aisle. So if you want to buy a toothbrush, it not only tells you it's available in this store, it guides you with augmented reality all the way to the shelf where that toothbrush is located. Marketing, we talked about it. 3D visualization, we talked about it. Venue experiences, I mean, this is really amazing. If you think of things that can happen in museums, for instance, you have an artifact, you can show so much more information and so much more augmentation that can take the entire experience to a whole new level. And it's not just museums, it could be anywhere. It could be a retail store, it could be the experience you offer in a plane, for instance, and so on and so forth. We talked about immersive experiences, gaming, social virtual reality experience. We talked about movies, creating three-dimensional theme parks, live events, talked about it. Virtual tours, offer a three-dimensional tour before somebody travels, offer a virtual tour of real estate before you buy, and so on and so forth. So these are a whole host of use cases. And if I keep on talking about them, I can have a separate talk on just use cases, given how broadly applicable these technologies are. So the question really is, what will you define for your own product that can improve the competitiveness of your product? Now, getting quickly into the process piece of it, I've followed the same value, how valuable it is, usable it is, viable and feasible. I've done the same process. And you start with the first step of defining the concept or defining your specific use cases or set of use cases. Identify what value you will add, to what customers, what partners you would need, what about the usability, how will the end user extract that value, how viable it is. If you're targeting an enterprise, what is the return on investment for the customer? If you're going to sell to a consumer, will he be really willing to pay that money? If it's free, will he be willing to spend the time on it? What impact you're having to your organization, from either it's from a cost benefit analysis or a business case, or if you're trying to get more users or usage time, you have to look at how viable it is for your organization, how viable it is for your partners, and identify that a set of use cases. Maybe you want to prioritize them, and identify the risks for each one of them. What are the unknowns? What is things that you're not knowing? And document that, and keep asking these questions as we go along in the process. The other thing you do here is to see if, given what you know, is it worth making a more intensive concept assessment? What does the concept assessment look like? What are the objectives? How much will it cost the organization? What is the time and schedule it will take? And based on that, you make a decision. Should we perform this assessment or not? And if it is yes, then you get into the assessment, refine all this again. And as you refine it, you also make an assessment whether you want to do a real prototype. And if you want to do a prototype, look at what risks we are trying to eliminate, what variable that we don't have enough confidence on, we're trying to gain confidence on. What is the objective? What exactly will the prototype do? How much will it cost us? What time will it take? And then you make a decision again whether to do that prototype or not. Again, you're competing with all the other activities that are happening that may also merit creating a prototype. So that's the evaluation that has to happen. Once you develop the prototype, you continue to refine it, take it to as many customers as you can, get the feedback, refine it, and you may have to iterate here, and that's okay. And then as part of this, assess what will it take to get the first product, that you can go to the market with. What is the scope, what is the effort, and so on. You would also want to ask questions around what is my go-to-market and what is my support. So all along the process, you keep on asking this question. Can it enable me to meet an existing need better? Can it enable me to meet an unmet customer need? Are there new customer segments that were earlier unattractive but now become attractive? Can it help me with my organization goals? In the enterprise context, will it enable my customers to improve their productivity, safety, and quality, and so on? So these are questions you keep on asking all throughout the process. But the big question, and the big question that you need to answer right now is, will you make it a competitive advantage for you, or will you let your competition make it an advantage over you? That's all I have.
Excellent. Thank you, Vikas. And again, it's really a very interesting talk, and I like the new spin on it. So again, thank you to our speaker, Vikas Batra, Senior Domain Manager of Innovation Scouting over at Nokia, for today's discussion on mixed reality interfaces and product management. And as always, the presentation will also be posted to our SlideShare channel. And a big thank you from me, Jeremy Horn, the product guy, and everyone else who joined us today, and the product mentor. And don't forget, if you're interested in being a product mentor, like today's speaker, Vikas, to product people of all sorts, all around the world, we're in over 20 different countries, please visit theproductmentor.com today and sign up to be a mentor. And also, if you're looking to fill a new product job with a great product person, visit our very own free-for-all job board at theproductjobs.com. And with all that said, I'll see you guys all at the next talk. Bye.